All right, I'm here with Cody from Earles Excavation, and he's just started with the septic tank hole. Cody, why don't you explain a little bit your process here of where we're at and then how you're going to tie the drain lines and things like that off.
So we always put the septic tank downhill from the house, which is going to be up here behind us. And then we have a main line going down. You see this first flag here.
Those are the two pipes.
Yep. So it goes to what's called a D box or distribution box.
Okay.
Kind of got a bunch of holes depending on the size. And then going horizontally here into the woods, we have our absorption trenches. So on this system, we have 4 60-foot long trenches. And we will have your header lines that will feed. Basically, one pipe goes into that box and disperses all the waste into this absorption trench. Yeah.
Okay. And so you'll be digging that yet today?
Yeah, we'll start that today. Probably won't finish them all.
All right.
And then we have your super long run to the future yurt. That'll take some time there, but
yeah, that's going to go up through here, and the house will be right here. So we're only about 30 feet away from where the septic tank will be from the house, and then everything feeds downhill from there. So we're using gravity. And so on the distribution lines, do they just go at a 90 degree or do they go off at a 45 degree? How does that work?
They'll go pretty much straight in line. Your header lines will, and then they will 90 degree turn into your absorption trench, because once it's out of this tank, there's no solid waste. It's all just liquid.
Okay.
Because that's the rule, is coming from your house to your tank can have no 90s, because solid waste will get clogged up. But if it's functioning properly, your solid waste settles to the bottom and your effluent flows out, which is just liquid, and basically creating a really good home for bacteria to live in your absorption trenches to clean that waste up by the time it gets back into the water table.
Great. And are you only going off to the right-hand side, or are you going both directions?
For this one, we will only go, if we're looking down the hill, just to the right. So we'll have 4 lines going down. They're 11 foot on center for this system, so they'll just 90 degree every 11 feet.
Okay.
Yep.
And why only one direction instead of both directions?
So it has to be, we dig these one, it's called digging on contour. So we'll shoot grade from that stake to this one. It has to be the same grade from point A to point B, because we're putting these on a little bit of a slope. It's 2 to 4 inches of fall per 100 feet on these. So if we went that way, because that hill drops off, you would be coming back up the hill.
Okay.
And they take all that into consideration when they design these things.
All right.
Yeah.
Great. Awesome. Thank you.
We'll get it done.
All right. Sounds good. All right. He's just taking out another tree. He's got a couple. Got one down here, another one over here, and starting to dig the hole, or dug the hole already for where the septic tank's going to go. Watch so I don't fall into this thing. It's a very deep hole. Good stuff. So what is, tell me, can you explain what he's doing right here?
We're gonna, that's the receiving end of the laser. When it's level on that metering stick, it'll beat a solid beat. If it's real slow, the grade's too low, it'll beat real fast. If it's too high,
Raise it up.
Laser level or transit. So this is a single slope laser, so I have to put this thing in line with the trench that we're digging.
Yep.
So I know how much fall I have to have from point A to point B. Fall meaning the bottom of the trench is going downhill. So I have to put this thing in line, and I have to tell it basically what % slope that I want to dig on.
And what are you putting this at?
So it's 2 to 4 inches and 100 foot. So
Okay.
minimum 2 inches of fall, maximum 4. Well, these are 60-foot trenches. So at 50 feet, it's a minimum of 1, maximum of 2. So I know there's a little margin of error there, so I'm going to set this at like 2.5 or 2 1/4 inches of fall.
Okay. And you don't want too much of a slope either?
No.
And that's because it puts too much pressure on the
So
end of
if
it?
it's got too much of a slope, as that effluent comes in, it's just going to run to the bottom of the trench and
Okay.
pool there.
All right.
They've done, originally these, this is a chamber system. Originally they wanted these chambers put in level, which didn't make a lot of sense, but originally they thought, well, it will just creep
Sure.
as it's needed
Yeah.
to.
From the back pressure.
But since then, they have decided that's the proper amount of fall, not to rush too far to the bottom, but
Right.
so it doesn't pool up here at the top as well.
Okay.
Yeah.
Awesome. Thank you.
So your D-box will go here, and you can kind of see you've got some lines going down.
That's the distribution box.
Yep. So you're gonna have your first line closest to these stakes will go down to your second one, 90 in, which is right here. And then your third line will 90 here. Fourth line will 90 at the ends. And this is what I'm talking about, contour. I don't know if you can see that painted line,
Oh, yeah.
but it kind of curves up the hill. So the way we do that is we check grade at the beginning of the trench, and we just walk through there with that grade rod, and wherever it tells us it's perfectly level, we make a paint mark, maintaining that 11 foot on center, which is what the OSC said.
Okay.
So as long as it didn't get closer than 11 feet, we're fine. They kind of fan out at the end,
Uh-huh.
but that's just the lay of the land, kind of does what the
So you
earth
just
does.
work with the land
Yep.
to kind of figure out the best layout?
And if you lay it out and for some reason you get closer, and we start at 11 feet on center on the header ditch side to save you and I money, because if it fans out here, it costs more because it takes more pipe.
Sure.
So we always try here. If it doesn't work out, then we'll try 11 feet on the opposite side, and it may have to fan out here, but
Okay.
luckily it worked out 11 feet on center over here.
Now, would you say this is sort of typical of this area for
Yeah.
a build out?
Absolutely, yeah. This is not too steep comparatively for the region we work in. Unfortunately, most of the time we kind of sucking the seat up a little bit because getting nervous, but it's not too bad here, and it's just rare. I think I've done less than a dozen systems where my lines were perfectly straight, just
Yeah.
because it's rare.
Yeah.
Usually if it's perfectly straight, it means the land's flat, and then you get into a whole nother type of system usually. So,
Okay.
yeah, but nothing too funky here, so it should
All
be
right.
good to go.
Good deal. Thanks,
Yeah.
Cody.
Mhm.
All right, breaking ground on the septic system drain field. Good that he's not hitting any rocks. That's the main thing that'll slow things down. Little progress update. They're leveling along the bottom of the trench using that laser level. So he puts that in the bottom of the trench, and it's shooting a straight line across, so they know what depth they need to be at, and they have it already set. So the beeping, when it makes just a clear solid beep, means they're in line, but since it was repeatedly beeping, that means he's got more to go. Still not there. Oh, still a little more to go. He's there. He's good there. All right, so they're installing the chambers, and I'll ask Cody what exactly a chamber is, what the purpose of it is, in just a minute, but thought you'd see this progress here, and it's going along pretty good so far. So I almost fell in a hole. Just digging out that last little bit. All right, Cody, tell me what this chamber is all about.
So alternative to the traditional type of septic system where you dig a trench, you put 6 inches of stone or 7 inches of stone with a corrugated pipe that has holes in the bottom.
Okay.
On top of that, then put more stone on top of up to the top of that pipe.
Yep.
That's your traditional version. This is just kind of, I don't want to say a cheaper alternative anymore, but it lets you do a little bit less, like the less number of absorption trenches.
Okay.
Basically, it's just making a underground chamber for that effluent to go in, grow this bacteria, and clean. It's good bacteria cleaning what you don't want going back into the ground.
All right.
And that's really the whole function of it, is just making an air pocket under here to create a good home for bacteria to live.
But what you were saying earlier was that if I look that whole length, that it's very, very likely that the effluent never really reaches this end, depending on the volume
Depending
of water.
on the usage of the system. I mean, they over-engineer these things for a reason. You know, say you've got friends that move in for a year. It might reach down here eventually.
Yeah.
But I have never repaired one where I saw the effluent really reach the end.
Or teenagers that take showers for an hour and a half.
Exactly. Yeah.
Something like that. Okay.
Absolutely.
Cool.
Yeah.
And then that's just a cap to end.
There's just
You
an
got to
end
cap it.
The end's capped, and they're the same on both sides. This is like a little splash guard that you put on the front. At the beginning of the
I
tank,
see.
you put these here, so where the effluent comes in doesn't like erode a hole.
Yeah.
But you don't need it on this end, obviously.
I see.
So,
Yep.
it just caps it off here. And we'll put some dirt around the edges to hold it down before we backfill it.
That's
pretty
it.
much all there is to it.
And then we don't have to put gravel or anything over the top of this.
Nope.
This is just backfill it with dirt once the inspection is done.
That's it.
And
Simple
we're good
as
to
that.
go. Awesome. Thank you.
That hole coming out of this side, it's 2 inches lower than the hole coming in.
Okay.
But when you come, since we're on such a steep slope, we've got there's going to be 2 T's inside of that tank.
Okay.
The inlet has to be 2 inches higher, 1 to 2 inches higher than the outlet.
All right.
But when you come up the hill here, and you're coming down the hill here, it kind of eats that 1 to 2 inches up. So we tilt that thing just a smidge down the hill, and it kind of makes up for that difference.
Okay.
Yeah.
Great.